Hi, I'm Carrie Braycheck, Director of Aerospace and Defense Solutions at Jama Software. In this video, I'm going to introduce you to our space systems framework available in Jama Connect. In this video, we will explore the benefits of using our pre-built template to get started with managing requirements, test cases, and architecture using our best practices inspired from industry standards and guidance from organizations like NASA and the European Space Agency. With space systems exponentially growing in complexity, shortening development timelines due to mission need and customer demand, and cost reductions influencing the capabilities able to be delivered with the final design, programs need to be able to get started quickly and begin the real work of engineering the system. Development and engineering tools need to be robust enough to tackle that complexity, easy enough to deploy, and then not get in the way of that real work of engineering the system. Jama Connect and our space framework comes pre-configured with a ready-to-use template. The framework is comprised of a requirements data model that provides requirements leveling and decomposition, a verification and validation data model that provides traceability to those requirements, an architecture data model that provides mechanisms to support systems architecture, system functions, and allocation of requirements, and a data organization method that follows industry guidance with the best practices of data organization in Jama Connect. Let's see what this looks like in Jama Connect. The space framework comes with two pre-built requirement data models. The one I'm showing now represents a full spacecraft product breakdown structure. The example shows how Jama Connect can handle the complexity of a full NASA or ESA space program. The requirements data model allows needs and requirements to be flowed down and fully traced from the stakeholder expectations to concept of operations to system level requirements down to segment, element, subsystem, and component requirements. This trace data model, what Jama calls the relationship model, provides a mechanism to enforce consistency in creation of data, as well as a consistent method to trace that data. This allows you to do faster analysis, measurement of expected versus actual traceability, complex filtering, and easy trace matrix generation and reporting. The left side of the screen is the Explorer tree and is where the data is organized. The Space framework comes with this pre-built spec tree ready for users to start authoring content right away. You can see that it too is organized hierarchically from the highest level of abstraction at the mission level and then down to the component level. You can navigate this traceability in the tree as well. We recognize that not every space system will be developed by a single entity that requires this combined breadth of customer implementing requirements and those of the implementing organizations. Your organization might be merely developing only a component of a larger space system. For this, we have a second space framework for integrated systems. Let's look at this one more closely. In this CubeSat example that comes with the framework, it's easy to see how the data is organized in the Explorer tree in a system-subsystem configuration. Inside each of the subsystems, you can see the specific requirements, their verifications, architecture, and the design descriptions. Traceability throughout the entire project can easily be analyzed at any level. What I'm showing is the traceability from the stakeholder expectations all the way down the decomposition tree. I can see the system requirements, verification and validation test cases. I can see the architecture and the subsystem requirements, and even the test runs. These real-time trace views not only show requirements decomposition, but test coverage as well as allocation to architecture. The framework supports, as I said, not just requirements, but architectures, V&V, even risk management and security. We've pre-configured the way you organize that here in the tree. So if I wanted to see the system architecture, I am able to see all of the elements that are going into making up the system architecture of this CubeSat. I can also see how I've organized by system, subsystem within the tree itself. That enables me to easily reuse and do variant management as well. I also have in this particular CubeSat security. So if you need to have security requirements, or if you need to do heavy cybersecurity and you want to import things like NIST 800, You can easily do that kind of a thing. And risk management, threats and risks. Moving the development cycle with security earlier in that life cycle is a big deal. Or understanding how safety is influencing the design. We easily allow you to track risk management and threat analysis in Jama as well. The intent of this is to provide ready-to-use solutions to our customers based on customer feedback, industry trends, and best practices, such as those as ESA and NASA. This enables engineers to tackle the complexity of space systems, develop faster, and collaborate at the speed of need. If you would like to learn more about how Jama Connect can optimize your product development processes, please visit our website at www.jamasoftware.com. If you are already a Jama Connect customer and would like more information on the space framework, please contact your customer success manager or Jama software consultant.